In this video, we will demonstrate the kit connection capability of Atmel Studio, the active kit detection with the Xplained Pro. We're also going to take you through the device programming dialog, do things like read device signature and target voltage, check a device silicon version, and the fuses, or the equivalent of the config bits from the PIC world. Okay, so in Studio, I plug in my kit, which is an ATtiny817 Xplained Pro, and I will get a welcome screen popping up. So note here that we are able to create new Atmel Start example projects or create a new Start project using this board. What this does is opens Atmel Start with a filter of the board, and you can see the different projects available here. Notice also that extension boards, which are plugged in, here a Bluetooth extension board with BTLC 1000 or the IO Xplained Pro, are also detected. So now with the kit connected, we can go directly to the device programming, and we can see that there's an embedded debugger tool picked up, and we apply. And here we can read device signature and a target voltage. Here's some information about the embedded debugger and the device. Note that we can see the silicon revision of the device here, which is quite useful sometimes if there are any support tickets. Memories, you can program the flash and EEPROM files separately, or even the user signature row. And fuses are the AVR equivalent to config bits in the PIC world. For instance, that the oscillator is set to run at 20 megahertz as opposed to 16. We can see that there was the brownout voltage detection, etc. Also, lock bits when we're ready to go into production, or there's actually some production file. I'm going to talk about the differences between what you might be used to with PIC, with everything in the hex file, and what you have with AVR, where you have the flash in the hex file, but the EEPROM is in a .eep file. Also, you'd be used to seeing the fuses, information included in the hex file, and I'll just show you a little bit about a project setup later in the video to explain these differences. Creating an empty project for the SAM L21, I can show you a similar process here. Here the device information is the L21J. Memories, note I don't have EEPROM showing up here, and in most SAM parts we have EEPROM emulated in the flash. Here we have the fuses, and there's a security bit option. I did go through the different types of example projects in another video. So we just need a C executable project for the ATtiny817. And here we can associate a tool with the project. And that would be the same thing as if we'd gone right-click and project properties. So since I'm in the project properties, I can click on toolchain, and here under general and output files, I can see a number of different output files which are generated by this project. And note as well that as soon as I start without debugging, which programs the part, I can see this list of files here being generated. Firstly, the dependency list is also generated, and I can directly open, for instance, the device header file, and I can see all these different options here. So to understand what these different file options are, the EEP file is an EEPROM content at program time. The ELF file is something which contains everything, including EEPROM and fuses. The hex is just the content of flash at program time, and the list LSS is the disassembled ELF file. Map file is a linker map file. What did the linker do? Decisions about where to put things. And the SREC file is the same as a hex, but in a Motorola format. We're ready to start writing code.